In the lesson that we're going to look at today, we're going to be dealing with linear inequalities, and how we can solve them and solve for a specific value. But we're going to start off with an equation just as a review of how to solve this equation, and then we're going to relate all those steps that we use to an inequality and kind of show the differences to that. So with an equation, remember that whatever we do to one side, we have to do to the other as well. And we want to try to get our variable, in this case it's x, we want to get that all by itself. So we are going to say we're going to isolate x. That's the version or the way that I'm going to describe it. To do an isolation of a variable, we're going to remove everything from that x side, or from, in this case, the right-hand side. There is a -4 in this case, so we're going to add 4 to both sides. -4 plus 4 cancels out to 0. -3 plus 4 is going to give us 1. And so we're left with 1 is equal to 1/3 x. Now that fraction there, what I have shown in the past and the method that I would use, as I find it's a little more straightforward, would be to multiply by the denominator. So in this case here, we're going to multiply everything by 3, and that's everything. We need to multiply by 3. That's going to remove the denominator. We're going to get 3 on one side and 1x on the other side, but that 1 is just generic and cancels out. So we have x equals to 3. Now we could switch this around if we wanted to, so we could do x on one side and 3 on the other. We could flip-flop it. It's not going to matter. X is always going to equal to 3. That is a bit of a difference when it gets into inequalities. So let's take a look at this inequality right here. We have 4 is greater than or equal to x minus 2. Now that greater than or equal to sign is an inequality, and we have to treat it as such, but it does work very much the way that an equal sign does in an equation. It keeps the two sides separate. Whatever we do to one side, we have to do to the other side, okay? And that's what we're going to do to isolate our variable onto a side of an inequality. So let's start. What I'll get you to do is I'll get you to try this one, do a little bit of practice here, give it a shot, see if you can graph it as well, and then I'll come back after a bit of a pause and we'll see how you did. All right, welcome back. If you still need to pause the video, pause it now. But let's solve for x. So what we're going to do is, to get x by itself, same steps that we use for equations, we're going to use for inequalities. So add 2 to both sides. That's going to remove that -2. And when we do that, we're going to be left with x is less than or equal to 6, or 6 is greater than or equal to x, depending on which way we read it. So it tells us that the x value has to be smaller than or equal to 6 to make this inequality work. Okay, and we're going to go through confirming or verifying inequalities a little bit later. But for this one, I just want you to graph it out. So what you should have had is a graph that looks something like that, a little number line. 6 should be on there somewhere. We're going to draw a solid dot on 6, and then x has to be smaller than 6. So we draw our arrow that way. No, other way. That way. There we go. Okay, I got to figure out how my camera works here. But it's going to go that way. Okay, which is going to represent that it's smaller than it. Okay, so if I'm asking you to graph it, please graph it out like that. Let's try this one. Solve for y, graph it out, and then pause the video, solve for y, graph it out, and then come back and we'll try to see how you did and if you got the same answer that I did. Welcome back. Hopefully you're able to come up with an answer for this one. This question here has a coefficient in front of the y, so we're going to have to remove that, but let's do that a little bit later. Let's start by removing the 3. Okay, so we're adding 3 on the right hand side, so the opposite of that would be to subtract 3, and when we do that, -5 minus 3 is -8, is less than 2y. Now you'll notice this one's just less than, there's no equal to sign, so it's there's one less option to our answer. Next step, we still need to get y all by itself, so we're going to divide both sides by 2. What this does is it cancels out the 2 on the right hand side, because 2 divided by 2 is 1, so this is going to leave us with 1y, and that's what we're going for. That's always our goal. So we have 1y on the right hand side, and on the left hand side we're going to have -8 divided by 2, which is -4, and so y is greater than -4 would be our answer. We could write it out either way. Now you'll notice that I flipped the sign when I move the y over, because the y has to be the bigger piece. So we have to, if we're going to switch the sides, we have to flip the sign. Let's graph it out. Our graph should look something like this here. You should have -4 on the graph somewhere. At -4, we're going to draw an open circle because y does not equal -4, but it starts there. That is our kind of our benchmark. And then it goes up. Okay, so it's going to go that way. It's going up. And so everything above -4 is going to be an option for this question. Okay, hopefully you're able to get that. Again, if you are having struggles with this, if you do have questions, please contact someone, whether it's your math teacher. If I'm your math teacher, you can contact me to try to solve and figure out where the mistakes might be made, and then working towards getting them right. All right, here's our next one. I just want you to solve. You don't need to graph it out, but let's solve for x, and then we'll talk about confirming our answer a little bit later on. Welcome back. Here we have a fraction, which means we're going to have to remove a fraction, and that's okay. Let's start off by removing the constant, and to do that, we're going to subtract both sides by 3, or subtract 3 from both sides, I should say, which is going to make it cancel out on the right, and on the left, we're going to get 5. Next step, we have that fraction there. So I've shown kind of a two-step approach to this one. We could divide by a half, but instead, I would just recommend get rid of the denominator. And so let's multiply both sides by 2, or every piece by 2, and it's going to give us that x has to be less than 10. All right, so here's our answer, right? We know that x has to be less than 10 to make this whole thing work. Let's verify our solution of x is less than 10. Okay, so I have it up there on the white part again. And let's give a correct and incorrect answer to check. Now, if I was doing this with you in a class, I would actually ask you for a value. But what I'm going to do is I'm just going to come up with an answer where x is less than 10. I'm going to use 4. Okay, it's a random number. You could have used really anything less than 10. You could use 9.9. You could use -100. I'm going to use 4 as it's less than 10. Okay, this number should work for this inequality. Let's try. Let's plug it into our inequality here. So we're going to plug it in for x. So instead of x, now we know what our number is, or we're giving a number that should work. 1/2 times 4 is going to be 2. 2 plus 3 is 5. And is 8 bigger than 5? I'm hoping you're saying yes, whether loudly or whether quietly. Yeah, it is. So this works. So we know that a number that's smaller than 10 does work, which means that, yeah, good job. Okay, we got it. That's awesome. Let's try a number that is bigger than 10. Okay, we know that x should be less than 10. So let's look at a number bigger than 10. And I'm going to use the number 15. Okay, technically, if we've done it correctly, 15 should not work. It's bigger than 10. X is supposed to be less than 10. So let's try it here. Let's plug it in for x, and let's see if this one is going to work. Okay, 1/2 times 15 is 7.5. We add 3 to that, and we are told that 8 is greater than 10.5. Is that true? I'm hoping you're saying no, or shaking your head, or really just inside your head maybe saying no. No, it doesn't work. So this does not work. Awesome, good. 15 should not have worked, okay, based on what we know, and that's good that it doesn't. So awesome job. We got one answer that did work, 4, and one answer that didn't work, 15, and they are exactly where they should be in accordance with our inequality that we got as an answer. All right, so that's a way to check. Use one that shouldn't work and use one that should work to check and see if we got it right. If the one that should work doesn't, maybe we need to switch our sign around, and we'll show an example of why we might need to do that in just a little bit. Here's our next example. I'd like you to try this one, graph it out, and let's see how you do. And this one deals with x's on both sides. All right, welcome back. Let's try it out. Let's see if we can come up with a solid answer for x that is an inequality. Because we have an x on both sides, we need to combine those together. Okay, so they are terms, so we will have to subtract one of them. They're both positive, so we'll have to subtract one of them to move it over to the other side. Now, what I like to do is I always like to make sure I have as many positive as possible. So if I subtract 6 from 3, I'm going to get a negative. But if I subtract 3 from 6, I'm going to get a positive. So for me, I'm going to subtract 3x from both sides. That means that it's going to cancel out on the right, and 6 minus 3 is 3. So we're going to get 3x minus 5 is greater than 4. Now we only have a single x, so let's try to get it by itself and isolate it. Add 5 to both sides. 3x is greater than 9. Divide by 3, and we get that x is greater than 3. Okay, so we've got x all by itself. This should be our answer. Any number bigger than 3 should make this work. Graph it out. So I have 3 on my graph somewhere. It happens to be the second one. It is not equal to, so I'm going to draw an open circle, and then the line goes up, so it's going that way, because x could be bigger than 3. So it could be 4 or 5 or 6 or really anything that is there. Okay, so good job. Well done if you were able to get that. Let's try another one. All right, this one has a little bit of a tweak. Check your answer afterwards to see if you get it right. Do the little practice, pause here, and then we'll come back and see how you did. All right, welcome back. Let's see how you did. This one brings in a challenge which is unique to a linear equation, and I want to go through and show you, or sorry, linear inequality, and I want to show you what that is and something to watch out for as you're going through this lesson, and if you're getting tested on it in the future. So let's start off by solving for x. Let's do exactly what we normally do, and then I'll show you the change when it comes around. First step, add 8 to both sides, right? We're trying to get x by itself, so we want to get rid of that subtracting 8. So let's add 8 to both sides, and we're going to be left with this here. 12 is less than or equal to negative 3x. So what would be our next step? Well, our next step is to divide by negative 3, okay? And when we do that, okay, here is the little tweak. When we divide by negative 3, we're going to get negative 4 on the left-hand side. But you might notice, if you are paying attention there, that I have switched my inequality sign. Yeah, I did that. If you didn't do that, okay, and you had x is greater than or equal to negative 4, took a value that's greater than negative 4, let's say 0, plugged it into the inequality, you would get that 4 is less than negative 8, I think the answer would be, yeah, if we use 0. That's not true, okay? 4 is greater than that. When we, and here I'll put that on there right away, okay, that little inequality there, when we multiply or divide by a negative number, okay, or negative value, the inequality needs to get switched. If we were to divide or multiply by a negative number again, we would switch that value again. Okay, we do it every time that we multiply or divide by a negative number. So because I divided by negative 3, I had to switch the inequality. So instead of it being a less than or equal to, it's now a greater than or equal to. And that we need to do in order to solve. Okay, so we should be able to find a number that's less than negative 4, so more negatives, and it would make this inequality work. Anything bigger than negative 4 would not work in this case, even though the initial way we would have solved it would have. So there's our little trick, our little tweak. We have to make sure about that when we're doing our practice and when we're doing our questions. Here's another one. Okay, take a look at this one, try it out. Remember what we just learned about switching the inequality. You may have to do it again, maybe. Practice it, see if it works, take a value and plug it back in to check your answer. All right, welcome back. We're going to go through this one and we're going to try to see if it will work or how we can solve it to get x again all by itself. Let's start from the beginning, right? Let's get rid of that positive 4. Yeah, so we're subtracting 4. Now we're subtracting 4, so that doesn't change our inequality. Subtracting and adding does not matter. It's only about multiplying, dividing, and negative. So when we do this, our inequality stays exactly the same. And we get negative 2 on the left side and negative 2/3 x on the right-hand side. Our next step is we're going to multiply by the denominator. Now, because of the way it is, because we have a negative on the left and the right, I like to try to get rid of those. And so to do that, I'm going to multiply by a negative number, and that's going to be negative 3. So I'm going to multiply by negative 3, which is going to remove the denominator and the negative from the right-hand side, and it'll remove the negative from the left-hand side as well. So negative 2 times negative 3 gives us positive 6, and negative 2/3 times negative 3 gives us positive 2. And you'll notice that I switched the inequality again, right? I multiplied by a negative, so I switched the inequality. And it's very important that we do that when we're going through this lesson, okay? Or when we're going through these types of questions dealing with inequalities. All right, I'm not quite done yet. We need to divide. We're going to divide by 2. Sorry, it's a little bit underneath that circle, but that's okay. So we divide by 2, and you'll notice this time I did not switch the inequality, and it's because I've divided by a positive number. Okay, so then the inequality stays exactly the same. So 6 divided by 2 is 3, so x has to be greater than 3. So find a number bigger than 3, plug it in for x, and determine, does this value work, or does this inequality work for that? All right, happy learning, happy practice. If you have questions, if I'm your teacher, feel free to ask me either in class or via email. If you're just watching this video, that's awesome. I'm really glad. You can gladly reach out to me and try to ask questions as well through YouTube and through the comments, and I will try to respond if I can help in any way. Thank you very much, and happy learning.